Hi class, here's going to be a lesson on graphing exponential functions. It's lesson 10-6. So here's our first one, graph y equals 3 raised to the x. Let's immediately put it into our graphing calculator and see what it looks like. Y equals 3 raised to the x power. I press graph right now. And there's a picture of what my graph is supposed to look like. Notice how my curve is going up and to the right. And what I told you from the first day of class, if our base is bigger than 1, it's going to be showing exponential growth, which is up and to the right. What's our base? Our base is 3. 3 is bigger than 1. So this is kind of tying in what I told you for that first day of class. Okay, now that we see a picture of what our graph is supposed to look like, let's now sketch it on our graph paper. So what I want you to do, class, is the graph paper that I give you, I want you to plot as many values as you can on this graph. It might sound overwhelming at first, but it's really not that many points. So the way we find our points is we press second graph, and that's where our table is. And so notice how we have all these points. We'll first start off by graphing the most convenient ones, and that's going to be these ones right here. So at 0, 1, 1, 3, 2, 9, 3, 27. And hopefully all of those points make sense to us. When x is 0, 3 raised to the 0 is 1. When x is 1, 3 raised to the first power is 3. When x is 2, 3 squared is 9. Whoopsie. When x is 2, 3 squared is 9. And when x is 3, 3 cubed is 27. So we get this look. But we can also put negative values in for x. So let's plot some of those. Those aren't as easy, I guess. We get kind of some decimals, but we could try our best. So let's plot these 2 points. Go left 1, up 1/3, and go left 2, up 0.1111, which is up 1/9. A little bit trickier, but let's try as best we can. Left 1, up 1/3, something like that, and left 2, up just above the x-axis. Kind of tricky to do, but try as best you can. So then it goes down, and we get this type of a look. I want you to notice something here, class. What happens as you go even more negative? As it's at -4, it's at 0.1235. Let's scroll even further up, which means I'm going more negative. As I even get to -10, look at how small that number is. 1.7 times 10 to the -5th. That's a very, very small number. However, it is still positive, isn't it? It's not like it's a negative number. So as I continue scrolling, it's just going to continue getting smaller and smaller and smaller, but it never goes negative. So that means that our graph is approaching what is called an asymptote. That asymptote is the x-axis. It's getting closer and closer and closer to 0, but it never touches it. It always stays positive. So if that is our horizontal asymptote, we're going to say it's y equals 0. There's our asymptote. So now I could identify what my domain and range is. How far does my curve go to the left? Well, infinitely, so it starts at -infinity. And then how far to the right does it go? Well, I can keep on putting in x values, 3 to the 4th, 3 to the 5th, 3 to the 6th, 3 to the 7th, 3 to the 8th, and it's going to continue going up and to the right. So it's going to go from -infinity all the way to +infinity. So there's no number that my domain can't be. That means that x such that x belongs every real number, or all the real numbers. So now for my range, it's not all the real numbers because there's no negative numbers. It starts just above the x-axis. So it never hits 0. It gets close to 0, but it never touches it. So if we say it starts at 0, but it does not ever touch 0, so that's why we have a parenthesis, and then it goes all the way to +infinity, because it goes up forever and ever and ever. So for our range, we would say that y such that y is all of the numbers that are greater than 0 or above 0. So it's not greater than or equal to, it'll never equal 0, it's greater than 0. So there's how you do problem number 1. Let's take a look at problem number 2 now. Let's graph this. Y equals 0.25 raised to the x. So y equals, y equals 0.25 raised to the x power. We graph this. Notice how my graph is going down and to the right. So as it goes down and to the right, that's supposed to show exponential decay. And from the first day of class, I told you that when our base is a number that is less than 1, that we have an exponential decay graph. Well, 0.25 is my base, and 0.25 is less than 1. So again, it's staying consistent with what I told you earlier on in this class. All right, let's graph as many points as our graph paper lets us. So going to our table, second graph, we can plot, right about that -2, I suppose we could start plotting for our x value. So here we have a -2 up 16, a -4, or -1 up 4, 0, 1, 1 up a 4th, and 2 up a 16th. We could attempt to plot those points right there. So let's try that. -2 up 16. -1 up 4. 0, 1. At right 1, we're up a 4th. And at right 2, we're up a 16th. It's kind of difficult to plot those fractions, but try as best you can. And once again, if you were to continue scrolling to positive infinity for our x values, so that means continue scrolling down. As you scroll down, it gets small rather quickly, doesn't it? At positive 12, it's already 6 times 10 to the -8th. So that's a small number. Once again, though, it is still positive, so it's never going to reach the negative numbers. It's never going to go down into the 4th quadrant. Your graph is going to approach the asymptote of y equals 0, but once again, it's never going to touch it. So you have an asymptote here at y equals 0. And this goes up and to the left. Okay, so what's our domain? Our domain, this goes infinitely to the left, and then this goes infinitely to the right. So it goes from negative infinity to positive infinity again. So it's all the real numbers. X such that x belongs to all real numbers. For my range, it starts just above 0 again. Right? It never hits my asymptote, so it starts right here and it's going up, 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 and then it obviously goes up forever. So it starts at 0, it doesn't include it, so we put a parenthesis, and it goes as high as positive infinity. So y such that y is everything that is greater than 0. And there's how you graph exponential functions. Be sure to let me know if you have any questions when you get to class tomorrow.